we're going to look at how to graph a single linear inequality in two variables. Now, before we get into graphing linear inequalities, we ought to take just a second to look at how we graph linear equalities. If you have a linear equation, and if it is written in the form y equal mx plus b, then we can look at it and easily identify a slope and a y-intercept. Those two pieces of information alone will allow us to graph the linear equation. So if I had y equaling a negative 1/3 x plus 5, I could come over and graph it, draw my x-axis and my y-axis, and put a few tick marks on the axis to guide ourselves with. And this particular equation has a y-intercept of 5, so I'll start up at 1, 2, 3, 4, 5. That'll be my first point. The slope is negative 1/3. And since we move always to the right, a negative 1/3 means come down 1 and then over 1, 2, 3. Down 1 and over 1, 2, 3. And we have some points with which we can draw the line. Actually, 2 is enough, but 3, let me fudge this one a little bit, is a good way to sort of to double check yourself to make sure you have the correct line. Now, this line represents, graphically, all the solutions to this equation. In other words, we only drew 3 points here, but this line literally has on it an infinite number of points. Each point is an ordered pair, meaning an x value with its accompanying y value. Any one of these points can be plugged back into this equation, replace the x and the y in this equation, and you'll get a true statement. True statement meaning you'll get actual equality. So if the points that give you equality are on the line, then what must be true of the points that are either above it in various locations or perhaps below it in different locations? Well, if the points on the line give you equality, then above the line and below the line there must be inequality. Inequality meaning using those x and y values does not satisfy this equation. And by inequality we mean less than, perhaps greater than. So we should take time to figure out where is the less than and where is the greater than. And one way to do that could be to pick a point that is clearly above or below the line, try it in the original equation, and see what we get. Now it looks to me like, since our y-intercept right here was 5, that the point 1, 6 should be a safe bet for a point that's not on that line. Let's see what happens. Plugging in the 6 for y, and actually probably shouldn't put an equal there because we're not going to get equal. We're questioning what we're going to get. 6 in for y and 1 in for x. When we take a negative 1/3 plus 5, we get a 4 and 2/3. Now, how does this 6 compare to 4 and 2/3? Well, clearly it is greater. So it would appear that above the line you have greater than, and that would just stand to reason that below the line you have lesser. And if you stop and think about it, this makes true. This should be true. If the original equation had said y greater than, well, stop and think about what happens on your y-axis. Your positive values go up. Your negative values go down. That means as far as the y-axis is concerned, greater than should be in an upwards direction, and less than should be in a downwards direction. So having established that, let's look at another example. I'm going to start off with another example where the inequality is given to you in an easy, ready-to-graph form. Let's look at y less than or equal to 2/3 x plus 4. And let's clear that 2/3 up a little bit. Again, the y-intercept and the slope on this one are readily apparent. The y-intercept is going to be 4, so I'll go up to 1, 2, 3, 4. The slope is 2/3, so from there I'll go up 2, 1, 2, and then over 1, 2, and 3. Now, with your inequality notation, this one has an equals to accompanying it. That tells us that we can connect these dots with a nice solid line, because the presence of that equal to means that the points on the line itself are going to be included. Less than, of course, as we've already discussed, on your y-axis, the numbers get lesser as you go down. So to represent our solutions, and here we finally show how the solutions are going to be represented. To represent our solutions in this type of problem, we shade the indicated region. So in other words, we're shading this region to show that all of our solutions are going to fall either on the line or in the region below the line. Now, of course, the equations, or the inequalities, are not always given to you in this ready-to-graph form. This is where you have to be careful and remember a couple of your rules of inequalities. For example, if we had 3x minus 2y greater than 6, we would first move the 3x over by subtracting it, or by adding a negative 3x, however you want to view that. The next thing we need to do is get rid of the negative 2, and of course we'll do that by dividing. But remember, with inequalities, whenever you multiply or divide by a negative, your inequality symbol has to turn around and face the other direction. So what started off as a greater than problem is actually turned into a lesser than problem because of my division by a negative number. So I'm ready to draw it. Put some tick marks on the axis to guide you. Alright, our y-intercept is negative 3. From that point, I go up 3, over 2, there's my next point. Now, in this particular case, there was no equal to, not in the original problem, and so you won't have one now. Because of that, we connect the dots with a dotted line. That represents the fact that the points on the line itself will not be included in our solutions. It says less than, and I know my symbol is oriented in the right direction, so I will simply shade in the region below the graph to represent the location of my answers. As a matter of fact, if you want to, you can check to see if you got the right region. You can pick a point in this region, plug it in, and I suggest you plug in the original inequality. You should see that it works. You could also test a point in the other region, and you would see that it wouldn't work, as it shouldn't. Let's try 0, 0. Plugging in 0, 0, I get 0 greater than 6, which is not a true statement, but since my point came from the wrong region, it shouldn't have worked. So that's exactly what I expected to see happen. So basically with these inequalities, if you can graph the linear equation, you are about 80% of your way there. The rest of it is just going to be a matter of shading the correct region. Now there is one or two examples where people can easily get confused, going back to some of the two special cases we've already mentioned. And those are going to be your horizontal lines and your vertical lines. Let's look at horizontal first. Let's say I had the inequality y is less than or equal to negative 2. Well, as you know, y equal -2 is a horizontal line through -2. Since I have the or equal to in here, I'm going to go down to -1, -2, and that's where my line's going to be. I will draw a solid line, and as we already know, less than, as far as the y-axis is concerned, is below. So that's what my solution would look like. Now if I had, though, x greater than 3, we all know that x equal to 3 is going to be a vertical line through 3, but it didn't say or equal to. So I will make it dotted to show that points on the line are not included. Greater than, with the y is above, but on the x-axis, when you're dealing with a vertical line, greater than is going to be to the right, where less than would have been to the left. So in this particular example, I would shade in everything to the right-hand side of that line, and every point in that region would represent a solution to this inequality. If you have any trouble getting your lines drawn, you can actually use your calculator. So let's come up with another problem to look at. Let's say I had y greater than or equal to a 2x plus 1. I could go to the calculator, hit y equal to, put in the 2x plus 1. Now we know it to be a greater than relationship, so I can go back over just to the left of where it says y equal to and hit enter, and I can go change it to shading, and it will shade above. And if you already knew where to shade, then that would be a good way of looking at what your solution should look like. So again, if you can get the linear equation drawn, you're most of the way there. The rest of it is just a matter of figuring out which side of the line to shade on.